for IHEA in New South Wales. And he'll be giving us a talk today about filter testing standards and his contribution as an IHEA representative on the ME080 Standards Committee, where they're developing standards for filter testing. Gregor's got 25 years experience in waste management and the recycling industries. And he also has a master's qualification in occupational hygiene and toxicology. So we're certainly in knowledgeable company here and lucky to have you on board, Gregor. So thank you for your time. I'll hand over to you to screen share and let you fire away with your presentation, and we'll talk later.
Thank you very much. Okay, just bear with me. Everyone seeing that?
Absolutely.
Okay. Yeah, why should the health industry care about a new testing standard for air filters? This is the ISO 16890 is the general standard for general filters. So we're not talking about HEPA filters or ultra high efficiency filters. We're talking about the general filter series, and at the moment the Australian standard is the one people use, and it's the G1 to D5, then the F6 to F9 series. So yeah, for my I was really pleased to get onto the committee on behalf of the IHEA, and it's been a really interesting discussion around adopting of the new filter. So first thing you've got to ask yourself, well, why replace the current Australian standard? What's wrong with 1324? It's 1324, it's based on an older European method called EN 779, which was developed in 1993. And these, they're not identical, but they're very similar, and they're testing sort of single particulates at not at the most penetrating size, but at 0.4 to 0.6 microns, and basing this filter performance based on that one particle. The new 16890 actually tests 12 different particle sizes between 0.3 of a micron to 10 microns, and a whole range in between. And yeah, it's a much more comprehensive testing regime that actually tells you how the filter is performing. AS 1324 and the European standard, it also ignores the electrostatic charge effects on a filter. So these are charges that are often placed on filters that makes them more effective in particularly screening out smaller submicron particles. What happens though is that filters, when you operate them in the real world, they can often lose that electrostatic effect, and then your filter becomes much less efficient, up to 25% less efficient in capturing some of those smaller particles. So as I say here, your ER7 may actually be a G4 after discharge. The other feature of 1324 is that it's basically got an accuracy it allows an accuracy of plus or minus 15% efficiency, which yeah, it's quite a broad range. The new ISO standard, it's down to the nearest 5% performance. So yeah, that's what that means in net effect. And looking at this next slide is the data I could gain in terms of actual performance according to the European standard. This is performance data to EN 779, but given the very similar method that the 1324 operates under. This is what the filters are supposed to be doing over here, and this is what the filters are actually doing when they tested them. And what you can see is a very a broad range of different performance. So like this is an AS F5 class filter. It's supposed to be capturing over 50% of ISO or PM10. And they found in the tests that they were achieving between 40 and 70%. So quite, not only was the range broad, but it also, some of the filters were, you know, below performance. Similarly, the F6s here in the 2.5 micron range, which is the one that gets deep into your lungs and the one you really have to watch out for. These really did underperform. The best performing ones were screening 50% of the 2.5s, but some were only screening 20% of the 2.5s. Again, and this is based on independent Eurovent testing. And the last one here, the F7, the PM1s were between 40 and 65%. So again, they're below the expected performance. And look, these tests, I don't think that anyone's gone out and tested Australian-made filters to AS1324 independently and published anything like this. But these sort of results you would expect also from the Australian standard, and that the methods are very, very similar. So having a look at how the new filter classes work, and I'll just show you some examples of those. There's basically 4 general categories of filters under the 16890 series. There's an ISO course, which has basically these are filters out of scope nearly. These capture less than 50% of the 10 micron particulates. So but it's possible that someone will be selling some ISO course filters in future, but they're not terribly effective. So the ISO PM10 filters capture a minimum of 50% of the 10 micron particulates. So I've just put a graph here. This is from AAF, and this is some of their filters that have been tested to the ISO classification. And this is the results from testing under the new ISO regime. So like this particular filter, the dry pack, it only caught about 36% of the PM1s, 44% of the PM2.5s, but it's capturing 65% of the PM10s. So this filter can now be classified as a EPM10 65. And this is the sort of designation you'll see going forward with filters. Instead of F6, F7, F8, you'll be talking this sort of naming convention. Similarly, the one down here, the DuraV, it's obviously not capturing enough PM1, PM2.5s. It's only 22 and 36%, but it's 72% PM10s. So it's a EPM10 70%. It took me a while for me to get my head around this naming convention, but after you've sort of got a grasp of it, it's pretty straightforward. Now, in my chart, or in my picture here on the right, there's no PM2.5 filters shown, but the same naming convention applies when we get down to PM1s, ISO PM1s. You can see down here, the Hydra V filter is capturing 81% of PM1s. It does capture, not 100% of the PM10s, PM2.5s, PM10s, but this is the critical one. So this becomes a PM1 80%. The DuraV filter up here, it's capturing 70% of the PM1 particulates. So once obviously filter manufacturers, these are the high efficiency filters, and they're meeting a minimum efficiency for that particulate filter size. Now, choosing the right filter is a separate question altogether. And it's another complicated question, unfortunately, because it depends on what supply air you need. And it also depends on the quality of the outdoor air. And this sort of makes sense. But when you see one of these tables for the first time, you think, goodness, why can't the world be simpler? But yeah, look, here's the outdoor air categorization, and you'll get data for outdoor air for different regions. And there's basically 3 different categories of outdoor air, 1, 2, and 3, with 3 being, higher particulates, PM1, PM2.5s, and PM10s. Outdoor air being the cleanest, with less than 10 and 20 of those respectively. And the supply air categories are also, these are arbitrary classifications, but as you can imagine, for hospitals, there is a requirement for supply air 1. So these are how they're defined in the Eurovent documentation. So so for most hospital facilities, if you're talking to your mechanical contractors and you're having a conversation around, well, what sort of filters are you looking at? As you can see, these are the categories going from the coarser, that might be an industrial environment, the supply air 5 category. But when we get down to hospitals, we go down from the PM10s to the PM2.5s to the PM1 filters. And with very good outside air, you're looking at a 60% efficiency PM1 would be expected for most hospital facilities based on this classification. But it may vary depending on your outdoor air quality, where you happen to reside. If you're in the middle of Melbourne, it's going to be different perhaps if you're out somewhere more regionally based. Okay, I'm getting back to the classification, but this is just a very, very influential graph and a very influential publication. And then I'm finding everyone, and when I mean everyone, I mean ASHRAE and folks like that are referencing this paper. And this paper looked at the annual cost of running a filter and graphed it against the mean relative risk of an infection. So what that means is that if you, and sorry, this is now the MERV grade of filters, which is the US grade of filters. So just don't worry about that. But essentially that's equivalent to a ISO course, and these ones up here are equivalent to an ISO PM 1, you know, like a 60 or 70%. So they're getting more and more efficient. But it's like a coarse filter, doesn't give you any, you can have a very high risk of infection, but a very low risk of operating. And what was nice about this study is the way that this graph just turned into a lovely curve where obviously when you go past MERV 13, MERV 14, it starts to get very costly because of the pressure drop to run those filters. Your sweet spot is down in this corner where you've driven down the relative risk of infection, and you're still achieving reasonable costs. And of course, once you get out towards HEPAs, no surprise that your running costs go up considerably. In a simpler world where there's abundant energy, everyone would be running HEPAs perhaps. So this is the basis for the ASHRAE recommendation. That's the American HVAC Association, very authoritative group over there.
Sorry, Joe, black tea.
And that's the basis for their recommendation for MERV 13 filters for general indoor environments. And what they talk about it.
I'm so good.
Sorry, I think we got someone who might need to go on mute. Sorry about that, Greg.
You're right. I'm having some technical issues here as well with cameras, so I'm going to switch screens. Yeah. So yeah, this graph has been very influential, and it's the basis for the MERV 13 recommendation for general indoor air environments. So where all else fails, if you're designing a new system, MERV 13's a great option. This is a graph, and it's like a translation table, if you like, between the different rating schemes. And it's showing us the Australian standard rating alongside the ISO rating, alongside the European rating, which is alongside the ASHRAE rating. So it's actually a really, really helpful graph if you're dealing with multiple different suppliers. Some filter suppliers will supply in MERV categories. Some will typically quote an EN rating, even though it's a legacy rating. Most of them are now going to the 16890 rating. But yeah, this is out of DA15, which is the ERA publication on indoor air quality. It's a fantastic publication and recommend it to members if you haven't got it, just for general advice and having in your collection. And yes, sorry, that was that's the current default recommended rating coming out of ASHRAE at the moment in terms of filtration through your HVAC system. Yeah, and that'll be gone, and you'll be using this classification running down that column. So typically, yeah, this is just a quick snapshot. This is a European filter supplier, and it shows you the ISO classes on the right-hand side here, how they're categorised for the different product and part numbers down here. It also has the legacy EN 779 rating down that way. So you can see this range here ranges for a PM10 of 60% running down to the much finer PM1 65%. It seemed remiss of me not to mention a little bit about the test method, but I don't want to talk much about this because it's complicated, funnily enough. But look, the ISO series 16890 actually forms a 4-part series. The part 1 is the one which we're expecting to go on exhibition next year for consultation, and it's a standalone document. It sets out how that series operates, but then there's a part 2, 3, and 4. And part 2 is doing the fractional efficiency, part 3, gravimetric, part 4, the conditioning method. Yeah, but just this is again straight out of DA15, and again, some of the most readable and helpful advice I got on what's going on with the new ISO series. But essentially, the first step of any filter coming through is that they're tested on a 0.3 to 10 micron scale for a non-conditioned filter. And you'll remember earlier I talked about the electrostatic charge. The conditioned, non-conditioned is all about the electrostatic charge. Step 2 is conditioning that filter to remove the electrostatic charge. They use isopropanol vapor, and then it's measured again. So you repeat step 1 without the electric charge. And then step 4 is an actual calculation of the actual efficiency of filter. And what they essentially do is split the difference between the electrostatic charge on and electrostatic charge off. And they say, okay, the efficiency is somewhere in the middle, not somewhere, is in the middle there to the nearest 5%. And then you're allocated an ISO grouping, and then that's reported within the nearest 5%. So yeah, the actual pathway of testing is far more complicated, and it jumps between these different parts of the standard. But I just wanted to give you a quick glimpse of what the actual testing standards what the process will look like. So what's next? We've got the committee has agreed to, and I hope I'm allowed to sort of report this, but there has been agreement that this part 1 will go on exhibition, and it's likely to occur next year. So you'll see Standards Australia put out a request for comment on that draft standard. We've essentially adopted it in we have not modified the ISO document. We've added a few extra things around how do we warrant something is actually being tested to that standard. The reason why parts 2 and 4 haven't joined the exhibition on part 1 is that the ISO committee is currently changing little technical bits of parts 2 and part 4, so they can't be actually consulted on yet. There'll be 2023 versions or late 2022 versions of those ones as well. So, but if AS ISO 16890 then gets adopted in Australia, there'll be a 2-year transition period for the 1324 method. So anyone relying on those has then 2 years to test their filters under the new standard and get it tested under the new standard. But yeah, that's the end of the formal presentation. I've promised you, Steve, I'd be under 20 minutes, so or thereabouts. So yeah, I don't know if there's any questions.
Well, thank you, Gregor. I've certainly got some questions, but first of all, I'll open it up to the floor and see if anybody's got any questions before I start firing away.
Yeah, Gregor, thanks for that, Neil. I'm assuming then that the filters will come out a gradual basis formed on the new ISO?
My experience is that 80% of filters I'm seeing in air handlers already have the ISO classification on it. Most of our manufacturers for the general filters actually coming in from overseas. Yeah. So they'll either have already ISO EN, the old European standard on them, or they'll be a MERV, they'll be an American manufacturer, and they'll have an ISO/MERV notation on them. What I'm finding is perhaps the Australian the ISO standard's been around since 2016, and the Australian standard, I have seen it used, but I haven't seen it on filters as such. I've seen it more from the mechanical engineering side, where they're still specifying in accordance to that. So yeah, I think the transition's happening with or without Australian standards, if you like.
Thank you.
I'm surprised to hear during the presentation, Gregor, that some of the filters are catching as low as 20% of the specified particles, and that's a real revelation to me. I've got to say, I always assumed we would be up in the 90% plus, but it's quite incredible to learn that.
It depends what you specify, but yes, if you specify like an F8 with an expectation of capturing a proportion of let's say the 2.5 were the ones that really were out of whack. And they're the dangerous ones too. They're the ones that get into your lungs. The problem with the current standard is that if you get plus or minus 25% with electrostatic charge, then another plus or minus 15%, depending on, how close you get to meeting the standard, all of a sudden you're potentially around 30% plus or minus, which, I mean, from a occupational hygiene point of view, and I originally prepared this for the hygienists, it's a bit of a clanger. It's not good enough, and we have had some really strong debates on the committee. There are some Australian manufacturers that do rely on the current Australian standard and that method, and they do obviously gain some advantage from using that. But it's really given ISO 16890 has been around now for 6 years and been adopted in Europe, it's well overdue that we did something very similar here with the testing standard.
Yeah, it certainly brought some interesting information to light. One question I have, you spoke a fair bit about testing filters. Now, since we're not talking about HEPAs, I know from my own experience, we really don't test the filters in our air handling unit. We leave them there until we see a pressure drop and change them. So under the new standards, will there be a requirement for in-service testing, or is this just something for the manufacturers?
No, this is a testing standard only. So it doesn't go to, there's an Australian standard about the hygiene status for your mechanical systems. It doesn't go to that. It's separate from that. The question is really, will we end up with one of the 16890 rigs in Australia? Can we locally certify, or do we have to ship everything? Does a local manufacturer then have to ship everything over to some lab in Europe or the US potentially to get it certified to this standard? And that could be an issue for industry and the local manufacturers. But look, one of the big arguments promoting for us to align ourselves with this is if we do have a local manufacturer that wants to export, they can't start putting the Australian standard notations on those filters. No one else recognises those. You might as well adopt something that's internationally recognised. And one of the things we're doing with 16890 in not modifying the method at all is that it will be consistent and a certification under the Australian standard 16890 will be recognised overseas as well. So there's an opportunity there for our businesses as well.
Yeah, good point. Good point. Anybody else got any questions for Gregor? All right. Well, I think the beauty of the lunch and learns with the IHEA is we all, get a good dose of information in a short period of time without inconveniencing ourselves and giving up a whole day. So, for half an hour's time from what I've just gained from that, Gregor, I feel that my time was very well invested there. So on behalf of the IHEA, I'd really like to thank you for your input into the committee and also giving us this presentation. It's given us some really good, as engineers, it gives us some really good background information. It means we don't get blindsided by things coming up and we can hopefully talk a little bit sensibly about what's happening in the future. So
indeed, yeah. Look, have a great Christmas, everyone, and go and enjoy the lunch and the sunshine if it's sunny where you are.
Yeah.